Alright, so good day everyone. Welcome to our new video for our recorded video lesson for this day. But before that, before anything else, let's start our day with the usual one that we used to do. No? So let's pray first before we discuss. So in the name of the Father, the Son, the Holy Spirit, Amen. Lord, we offer you everything we do today, all our works, our joys, and our sorrows. Everything will be an act of love for you. Holy Mary, Saint Joseph, Saint Joachim, and Saint Anne, and Guardian Angel, intercede for me so that I may be deserved to be helped and saved today and always. Virgen del Pilar, pray for us. In the name of the Father, the Son, the Holy Spirit. Amen. Alright, so for this day, we will be tackling a new lesson for this new quarter, no? Which will be inclined into statistics. But before we entered into the deep informations about these statistics, we are going to tackle about how to present a data, no? So, with regards to the presentation of data, there are three types of presentation of data. First in line is that we have what we call as textual, tabular, and graphical. More likely, in terms of presentation of data, the commonly used presentation of data is the textual type of presentation. Alright? So, let us tackle first the introduction with regards to this topic. No? So, when we are presenting a data, of course, we need data. No? And we need also a form wherein our data will be intact in a way that it has a format. Correct? That's why we have these types of presentations wherein this data that we have gathered will be able to look good when we are presenting them, and it will help our uh, information that it will be presentable for those who will be looking at it. Alright, so first in line, we have this textual presentation of data. When we say textual presentation of data, I want you to keep in mind that when we say textual, from the word, we are using text, or with this presentation of data, we use sentences or words. Okay po? So with this type of presentation of data, we will be able to describe the data that we have, no, using the sentences, but in a way that we are going to make a paragraph form, right? And in that way, inside that paragraphs, inside with those phrases that you are trying to give, no, there are the characteristics, there are the informations with regards to your data, wherein it will highlight what is the most important thing in your data. Okay po? Alright, so with regards to this textual, the easiest way for you to understand is that when we are in textual, we use sentences, paragraphs, or words to present our data. Alright? So, that is easy. That is how easy textual presentation of data is. Alright? Next in line is alright, so we have tabular presentation of data. So, the first type of presentation of data is the textual presentation of data. No? So, the second one in line is the tabular presentation of data. And, alright, so, and this second type of presentation of data is the commonly used, no, presentation of data in terms of research. No? Why is it commonly used? Because in terms of tabular data, no, it composed of parts wherein it will show what is the data that you have gathered, what are the characteristics of your data, and what are the enumerations in terms of quantitative, no, data. All right, so we have in line in our tabular representation of data. Now we have this what we call as frequency distribution table. When we say frequency distribution table, no, it shows data wherein it falls into such classes. When we say classes, no, there are classes wherein it shows like frequencies, no, wherein it shows also the means. So later on, we're going to discuss those parts, no, of this frequency distribution table, no. And there are also parts that will show what on your data what is the most frequent one that we usually see in your raw data. Okay, all right. Next, so with this frequency distribution table, we have what we call as the ungrouped frequency distribution. Because in this frequency distribution table, no, first in line, of course, we have the group and ungroup. All right, so there are two types of frequency distribution table. First is the ungroup, and the second one is the group one. So, to analyze and to see easily, no, what table or what kind of frequency table is the ungroup or group one, is that when we saw a frequency distribution table wherein it has the class intervals, no, wherein that class intervals shows that data or that distribution is group 1. Okay, but when we have such values in your table, which is more specific into your values, no, so it is ungrouped. If it doesn't have intervals such like 1 up until 10, so that is group. But if we don't have that such intervals like that one, no, that is ungroup. Okay po? Alright, so this is an example of ungrouped frequency distribution table. But before I show the table, no, I would like you uh, to stick in this mind that in terms of ungrouped frequency distribution table, no, or ungrouped frequency distribution, please set in mind that in terms of group data, more likely we are instilling the informations much smaller. Though we are using in a bigger wherein sometimes we are using bigger scales of data, and we were able to gather information with this ungroup. It's just that when we are in group data or ungroup frequency distribution, no, the data is not so wide. Okay po? We are using this, no, ungroup frequency distribution if the data is not that kind of big. Because, for example, you only have 15 datas. Probably you could be able to handle that one using the ungroup frequency distribution. But when your samples, no, when your samples are in a scale of 100 or 200 samples, probably you would like to use the intervals already because your samples are much greater already from what you expect to have in your data. Because if you're going to manually compute it, maybe you'll be confused. So with regards to the numbers of your data, maybe you'll have confusions. Okay. So with that said, this is an example of ungrouped frequency distribution. All right. So first in line, we have this table number. Okay. So it represents what number is this table? Is this the first table that you show? Second or third? Okay. And also the title, no? It indicates what kind of table is this one. It is really important in terms of your research, no? In terms of your, most likely in your research, yeah. You need to put title in tables because if you don't have, it will not be valid, and you cannot really tell what kind of table is that one, no? What's that for? It would be nice, no, to see that in each table that you have in your research will be having a title because it will be able it will help the researchers or future researchers that will be using your research or study, that it will help them to identify what is that table all about, or what is that data that you are showing in that study. Okay po? Alright, next in line is that we have this column header. Okay, so to identify what is this number in this column. What are these 350, 300, 250, 200, no? It shows in this column what is this numbers all about. Okay? Okay. And also the row classifier. Row classifier identifies in each rows, what are those? What is this 350? Does it indicate the sophomore, freshman, junior, or senior? Okay, so it is also important that you also have this row classifier. Okay? Alright. And lastly is the source node. Okay, so from what sources did you get this information? Okay, so let's have an example. No, with because this is an example of data or ungrouped frequency distribution. But let's have an example wherein we will be the one to make the ungrouped frequency distribution. Okay, so let's have this one. Alright, so with this data that you have, no? So let's construct a group and ungroup frequency distribution tables for the age of 50 service crews at Jolly Me Restaurant. Okay, so Jolly Me Restaurant. So let's focus first before let's not mind the group first. Let's have the ungroup data first, no? Frequency distribution. So, as you will notice, there are 50 service crews. Okay po? And it shows the age of each cruise. So, there are crews at Jolly Me Restaurant that has the age of 18, 25, okay, 19. Most likely, the highest score here is, or the highest age that the Jolly Me Restaurant contains is that there are employees that is on 25th age of their lives, no? And also, the lowest age that you could see or you could have in your Jolly Me Restaurant is that it has a 18 age of crew service. Okay? So, let's have it already. So, if you're going to put, no, or you're going to create an ungrouped data or ungrouped frequency distribution table, no, first is to identify what are the values that you have in the raw data, because this is your raw data. These are the raw data that you have gathered at the first place. All of them, 50 of them. This is the age. And there's a lot of 18s, correct? So, first in line, you're going to identify what are the values or what are the ages that you've gathered in your Jolly Me restaurant. First in line, the lowest age that you've gathered is 18, correct? So, identify how many Jolly Me crews, no, or crews at Jolly Me contains 18. Okay? Okay, so we know that it is 7. So, we have 1, 2, 3, 4, 5. Let's see, 6 and 7. So, basically, this frequency, no, the column header, it shows, when we say frequency, this is how often this 18 or age of 18 shows how many crews at Jolly Me Restaurant that their age is at 18. So, there are 7 Jolly Me crews. Okay po? So, aside from 18, of course, we have the value of 19. So, there are some crews that has the age of 19, 20, 21, 22, 23, 24, and 25. So, basically, the first step that you want to do in terms of making a group frequency distribution table is to gather all the values first. And this is what I call that these are the specific values that you might wanna write it down in a piece of paper first. Okay, so what are the values that you have gathered in your raw data? Okay, so as we wrote it down, we have 18, 19, 20, and so on. So how many values do we have in here? So we have 8. So 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 values. Okay po. So next in line, if we are able to, if you're done already, no, writing all the values that you have gathered, start identifying the frequency of your values. So at the age of 8, how many Jolly Me Cruise? How many Jolly Me Cruise that this restaurant contain? There are 7 crews that has the age of that are at the age of 18. How about for 19? There are 8 crews. For 20, there are 6. And so on. If you will notice, these are the frequencies. Okay? Alright. So how about this percentage frequency? So when we are dealing in percentage, let's go back in the lower level in terms of getting the percentage. I don't know if you will still remember this one. No? So when we are dealing in percentage, there are two things to remember as well in getting the percentage, right? So this is an information that you could found in the elementary days, no? Which we have rate and base, correct? Or if you want, PBR. Either way, okay? So in terms of getting the percentage or rate or base, no, we have this PBR or PRB. Okay, so when we are finding the percentage, we have a formula of rate and base. Correct? Right. Okay, so what is the definition when we say rate? When we say rate, this is what? This is the percentage of the base, or it is the value wherein we are getting the percentage or the percent, I'm sorry, we are getting the percent of the percentage. So coming from your base, if we say for example we have this 100% full battery, okay, let's say a battery 100% full, and it contains 500 uh, watts. It contains 500 watts. If this is your base, I'm going to ask you, what is the 50%? What is the 50% of this? What's the 50% of this battery? Okay. Oh, what's the 50%? Of course, if you're going to tell me, sir, the 50% of this battery is 250 watts. Correct? Okay. So what is the base, the percentage, and the rate? Okay. What is the rate? What's the base? And what's the percentage? So when we are talking about the base is the 500 watts. And the percentage, no? What is the percentage? What's the rate? 50%? Okay. So when we say the percentage, this is the percentage. Okay po? When we say rate, this is the number that contains percent sign. What's the percent sign? This is the one. Correct? Percent sign. Alright. So when we are dealing the percentage, it is the value of the rate from your base. Okay? So, when we are going to find the percentage of your frequency, okay, let's deal with this one already. So, when you have PRB, you're going to find the percentage of your frequency. So, what is your base? What is your base? Base is what? How are you going to identify base? If your 7 is your what? Percentage. So, you are trying to get the rate. This is the rate. Why is it percentage frequency, sir? Because we are referring from your percentage. So, 7 is your percentage. 7 is your percentage. And this part is your rate. So, what is your base? Your base, in order for you to find what is the base, okay? So, I want you to get your calculator. Okay po? Do you have your calculator already? So, once you have your calculator already, I want you to get the sum. The sum of your frequency. From the sum, we have this notation, or we have this symbol, or the sigma. Sigma of what? Sigma of frequency. So when we say sigma, that is the sum of a set of number, correct? So when we are going to find the sigma, or the sigma of frequency, sum of frequency. So what are you going to do? You're going to add 7 plus 8 plus 6 plus 11 plus 4 plus 5 plus 5 plus 4. So if you're going to add this all, what is the total number? Of course, 50. Here, isn't it that frequency shows how many crews are there? So of course, automatically, our base is 50. Okay? So we know, we were able to identify, no? Let's erase this one. We were able to identify what is our base. So if this is our base, no? If this is our base, I want you to get the value of rate. No, this is our rate, correct? I want you to get the value of rate, no, with the formula that you have, P R B. So we have base, and that is 50. What is our percentage? Our percentage is 7. So if that is 7, what you will be doing is, in order for you to find the rate, is 7 divided by 50. So the total number of your sample or data is at your denominator. Okay? So with that said, if you're going to divide that one, you will be having 14%. Okay po? 14%. But, Sir Jai, why is it in decimal form? So, if we're going to put it in decimal form, no, obviously, we're going to move 2 decimal places, and that would be 0.14. Okay? Sir Jai, why is it, it contains 2 zeros at the end, all of them? No? So, basically, in terms of statistics, in terms of research, it would be better if there are 3 to 4 decimal places, no, in order for us to be concise and exact in such values, because in terms of data we need to be more critic, no, we are not just getting the rounded value as just as it is. Okay. All right, so in that said, you will be able to identify what's the percentage frequency by dividing the frequency of frequency divided by n. What's your n? Or what is your sigma? F over sigma f. Okay? Now, what's your sigma f? The sigma is 50. Good. 50. Alright? So, I do hope that you understand already how to get the percentage frequency. Okay. So, we have next in line, we have group frequency distribution table. So, as I said, no, a while ago, when in terms of ungroup, no, we usually get, no, we usually use those ungrouped data when the scale is not so wide. Okay? When we are dealing in group frequency distribution table, no, well, you can deal with this one as well. It's just that in terms of group data, the only thing, again, no, I already mentioned this one a while ago, the only thing that you will be able to identify if it's group or ungroup is that there is classifications or category or class intervals. Not just in a column, but also in a row. Because if this is your column, no, and you have a lot of data from your ungroup, no, when we are going to turn it into group, no, it might be lessened in a way that in your row, you are not referring for just one or few data only or few frequency. For example, when you have 18, you only have 7. But when we are in group already, it will not just simply be 7 because you are classifying not just 18 but maybe also 19, 20 in just one row. Okay? Because there is an interval. Alright, so with that said, I'm going to show you already the example of table for the group frequency distribution table. Alright, so once again, we have this table. Alright, so these are the parts of group distribution, of group frequency distribution. Alright, so most likely when we have ungroup, those are we have this what we call as row classifier, correct? We have row classifiers to identify what are those, and we also have this column header. Okay, but I want you to stuck in your mind when we are in a group already, there's namings already in terms of numbers. In a way that in terms of row classifiers, we are not going to specify what is that values. For example, 18. That will be your row for your, that will be your value in the row of 18. It's just that when we are in group already, we have this what we call as intervals or class intervals. So for this example, we have 18 to 19. This is the class interval between 18 to 19. Okay po? So basically, it shows that within this column, this 18 to 19, it shows the frequency or how many persons in that 18 to 19. It shows 15 persons already. Okay po? So, what happened in this group data is that the data from the table was merged in a way that it was shrink, no, with this help of making classifications with an intervals. Okay po, with the help of intervals. And with this intervals, again, no, with this intervals, we cannot just simply say that it's 18 and 19. We have namings from them. So in your intervals, for example, 18 or 19, or let's just say this 24 to 25. When you have these left numbers or the starting numbers, we commonly call it as the lower limits or LL, lower limits. And your ending numbers or the right numbers or right values in your class intervals, that is what we call as upper limits or UL. Okay po? That in your intervals, it shows what are the lower values in your intervals. And that is the limit from your intervals. So for example, I will be giving a different example in this table. No, let's have 10 to 12. So the range, not really range, no, but the limit in terms of your class interval, the data that you are showing in your row, for example, you have a frequency, no, it shows that all of your data in that row has the limitation starting from 10. Starting from 10, no? This is the limitation. And ends up with the value of 12. Okay po? That is the limits. But what are the starting limits or the lower limits? Lower limits is the 10 and the upper limit is the 12. And again the identifications or the initials is the LL or UL. Okay po? Okay. So, with regards to this class intervals we can put that one in some initials so that it will be easy, no? When we are in class intervals, we could make it in an initials CI. Okay po? CI or class intervals. When we say class intervals, what is your class intervals? Class interval is 18 to 19. Okay po? 18 to 19. But in that intervals, we are telling things with regards to your values. Okay po? And that is what we called as class width. When we are telling class width, how many values that you have in your class interval or how wide is your class interval is. For example, let's go back to the example that I have given a while ago, no? So we have 10 to 12. And let's just say, for example, you also have 9, 6. Correct. No, let's have it 7. I'm sorry. So we have 7 to 9. Okay. So first in line, for example, this is your first row. First row is 10 to 12, and your second row is 7 to 9. If you will notice, the first row contains 10 to 12 and second row contains 7 to 9. So it shows that coming from your second row, once you hit the limit, which is 9, the next higher limit that you could have is the starting point of your interval, and that is your lower limit, which is the 10 already, no? So in this case, you will identify how many numbers can you see in this first row. First row, you have 10, 11, and 12. Correct? In your second row, how many numbers can you see? Or how many numbers or how many values does your second row contains? It has 7, 8, and 9. Okay. So maybe if you will be searching what is the formula in terms of class width or class size, no, you will be seeing some formulas like upper limit minus lower limit only. But the sense, no, you should have the formula of UL minus LL plus 1. Because when we are referring to class width, you're referring how wide is your class interval or what is the width of your class. Okay po? When we are referring to class, what is your class? Your class is 18 to 19. And this is the intervals of your data. That's why we are telling it is the class intervals. Again when we are referring to class, this is your class, okay? Or 18 and 19. But it refers to the intervals of your values because you have your values 18 up until to 19. So it was like the range or the interval of your values will be scoped coming from 18 up until to 19. That is interval, correct? And that will be your class, the first class that you will be referring. But when we are telling class width, it refers how wide is your class. How wide is your class? So when we are going to ask ourselves, how wide is your class in your first row and your second row? Okay. So for your first row, it has 3 values, correct? In your second row, contains 3 values as well. So when we are having class width or class size, it shows what is the size of your class. Okay po? Or what are the values inside? How many values can you see inside your intervals. Okay po? That's why when we have class width, we have the formula of upper limit minus lower limit plus 1. Let's try, no? So what's your upper limit here? Your upper limit is 19. So 19 minus lower limit. What's your lower limit? Your lower limit is 18. So basically, if you will be searching really, there's a lot of formulas that will be out there wherein upper limit minus lower limit only, no? But in the sense, you should know what is the real formula, no? So we have this class width from your upper limit minus lower limit, and the value is 1. But don't forget, you also have plus 1. So you're going to plus 1. So value is 2. So it shows that in your class intervals, you have two values. And what are those? What are the values of your class intervals? You have 18 and 19. What are the values of your class width? 18 and 19. But what is your class width? Your class width is 2. Okay? Again, values are different to your class width. Okay po? What is your class width? 2. What are the values in the intervals? Okay po? Gets already? Alright. So with that said, that is the basic things in order for you to be able to make a group frequency distribution table. No? So we have the column headers, no? The frequencies, percentage frequency. So same concept, just like what we had a while ago. No? So how many people can do you have in your raw data from the 50 service crews? There are 15 persons. Okay po, so same goes by to the next class intervals. We have 17 person, 9 person, 9 person. And in total, if we're going to find the summation of your frequency or your N, no, that is basically the 50. And if we're going to find the percentage with the use of formula of PRB, PRB, that's the basic one, no? You divide your frequency to your summation of frequency, or F over N, okay, to get the percentage frequency. Gets already? Okay. So, in that sense, this is ungrouped. This, I just showed the ungrouped and group frequency distribution table. Okay po? So, but before that, I'm going to show you some sort of examples, no, of frequency distribution table, because there, we cannot just simply tell, that's group, that's ungroup. Okay, so we have what we call also in frequency distribution table as simple frequency distribution table. When we say simple frequency distribution table, it consists class interval and frequency only. Again, what does simple frequency distribution table contains? It only consists class interval and frequency. There are only two, no? Two things that your table consists with, and those are class intervals and frequency. Alright. So, let's have this example, no? So, construct an ungrouped frequency distribution tables for the test scores of 50 students in statistics. We're going to make ungroup, no? Ungroup. Ungroup. So if we're going to make this in an group manner, how are we going to find? Of course, you're going to write it down. Correct? What are the values? So how are you going to scale it up? Let's try, no? Let's try to write it down. For example, this is your table. I'm not going to show it all, no? But this is the way. It only consists of what? Frequency, and it only consists of frequency and class interval. Class interval. Okay po? Alright. So, in this sense, no? In this sense, this is, for example, no? This is simple frequency distribution table, no? So, when we are referring to simple frequency distribution table, there are two things. What are those two things in terms of frequency distribution table? We have ungrouped. We have ungrouped and group. Ungroup and group. So, in this sense, what is ungroup once again? When we say ungroup, this is the specific values. And when we are referring to group data, this contains class interval. Now, in this sense, I'm going to ask you already, no? In this sense, that's why I will not write it down here, all the values, no? Because I'm going to show you what is this data all about. When you are referring to ungrouped data, what is your table shows? What does your table shows? Your table shows specific values. You're going to write it down, all of it, correct? But why is that in simple frequency distribution table, it shows two things only, class intervals and frequency. So in this sense, let's try to make this example first in group. Okay po, in group data or group frequency distribution. In that way, we will be able to find the data, or from the data we are going to we will be able to find frequencies of your data in just short time, because with the help of your class interval, if you're going to make it in group manner, no, we will be able to find the frequency of this one. Because if we're going to write it down, for example, I didn't write it down, no, if we're going to write it down like such specific values, it will take time, and it contains a lot of values already, correct? It will take time. I'm really telling you. Okay, that's why I didn't write it down. So, in that case, you're going to write it down. What are the values? This is the step number 1, no, for ungroup. If you're going to refer to ungroup, write the specific values. What are those values? So, what are those values? Starting from 9 and so on and so on. If it contains, for example, same values. Let's find same values in here, no? Let's say we have 31. If you saw 31, you cannot just simply have in your column as 31, then 31. No, you just put 31. Only one 31. Huh? Okay? Then you followed or proceed to the next value, which might be, for example, let's say it's 33. No? Okay? Or 32. Oh, there. Even though 32 is there, you just put 32. Okay? That is the first step. Next by 33. Okay? That's the first step, to write it down, all your specific values. Next in line is to identify what is your frequency. When we say frequency, how often your values or your specific values shows in your raw data. Because when we are trying to find frequency, how many values or how many times did your specific values shows in your raw data? So that's the time you're going to put. But in the sense, that's why I didn't write it down all, no, because it might take long time. So that's why let's focus for the group frequency distribution for this example. And we know that when we have simple frequency distribution table, it consists of CI or class interval only and frequency. Okay. Alright. So, in this sense, we have these intervals, which is 4 to 9, 10 to 15, 16 to 21, 22 to 27, and so on, up until to the highest score. Okay? So, in that sense, we will be able to find the frequency. How many values can you see starting from 4 to 9, in your raw data. How many 4 are there? How many 4? We have 1. Do you see any 4 or 5, 6, 7, 8, 9? You only have 4 and 9. So that's why your frequency is 2. Okay po? Okay. So same goes by. The scenario that you can see are just the same in your rows. No? So in that sense, you will be able to see what is the frequency. How many values are. Let's say, for example, no, let's have this last row, 46 to 51. It shows that the frequency is 4. Why? Starting from 46 to 51, let's try to find how many 46, 47, 48, 49, 50, 51, because your class interval is 46 to 51, correct? What are the values inside your class interval? We have 46, 47, 48, 49, 50, 51. So with these values, kindly check how many values can you see if you saw 46 or 47 or up until 51 in your raw data. Kindly count it as your frequency. Starting from 46 to 51. 46, 46, 47, 46, 46, 50. We have 1. Let's clear this out first. We have 1, 2. We have, let's see, 3, 4. Do we have more? I think we don't have it already. So that's why if you will notice, we only have 4. That's why our frequency is 4. Gets already? That's how. And with that sense, you can now check what is your total number from your raw data. Okay? Alright. So, if we have simple frequency distribution table, no, we also have this what we call as complete frequency distribution table. So, with this complete frequency distribution table, it doesn't only contains class intervals and frequency. Because when we say complete, of course, full package, it contains a lot of data that might help you to identify what is your research all about or what are you trying to show in your research. That might eventually help you that in your analysis, in your interpretation, that this data is all about this one, or the reason of this one is because of this mean or the average of this one. Okay. Okay. So when we are dealing in complete frequency distribution table, no, please take point. Take note in your mind, no, that your complete frequency distribution table has class mark. When we say class mark, this is the midpoint of your class interval. Later on, we will be showing what are those things. Okay? When we have class mark or the midpoint. Or you can simply put it as X. X will be your class mark or midpoint. Also, not just that one, no, we also have this class boundaries. When we are referring to class boundaries, later on, I'm going to show you as well. It is the boundaries that refers from your class intervals. Okay po? Next. Next is the relative frequency or the percentage frequency. So this percentage frequency, you are already aware what is this frequency, percentage frequency, no? But when we say relative frequency, please take note in your mind that they are just the same. It only defines what is the rate of your frequency. That's why it's a relative frequency. Okay? And last is this cumulative frequency. In terms of cumulative frequencies, there are two types because there are some datas or there are some frequency distribution table that shows cumulative frequency, but it doesn't shows whether if your cumulative frequency is in less than or greater than. Okay po, because we have this what we call as the organization of your cumulative frequency. Either it ranges from top to bottom or bottom bottom to top, or later on I'm going to show you. Alright, so with that said, let's have it already, no, in order for us to uh, make this complete frequency distribution table. Okay, so first in line, we have the first part, which is the range. Range, when we say range, no, it is the difference. Difference of what? The highest and lowest score. What is that highest and lowest score? Let's take an example with this one a while ago. Let's have this example, no? If you have seen this data, okay, what is the lowest score that you could see in this raw data? The lowest score that you might see in this raw data is simple as 4. That is your lowest score, correct? And if you will be asked, what would be your highest score? Or what's your highest score? What do you think? Oh, your highest score would be 50. Are there any values that are higher than or greater than 50? Are there? None. So therefore, the highest score that you have is 50 and your lowest score is 4. So if we are going to have this formula, your range, or R, no? R. Range refers to R. Your highest score will be your 50 and your lowest score will be 4. And if you're going to subtract it or get the difference of this one, the range, no, is 46. What is that range tells us? That is the range, no, coming from your lowest to highest score. It only defines what is the range, what is the distance between your lowest score to your highest score. Because if we know the range, maybe for example, you have this 50 students. Then the range of your lowest score to your highest score is that you have the highest score is 50, and the lowest score is 40. And what is the range? The range is only 10 out of 50 students, no? So the range is that you could see that the scores of your students are at high stakes or high scores because the range is just small. But when you see this range is just big, you can identify already that the scores of your students are relatively big already because you can see that there are some students who got low scores. Okay? Okay, sige po. So, next in line, now that's the range ha. That's the difference between the highest and lowest score. So, next in line is this class interval. When we are referring to class interval, I already explained this one. It contains the upper limit and lower limit. Again, upper limit and lower limit. It is the it is somewhat a cluster or a groupings, no, that classifies what is that class, no, that is defined with an intervals. Okay po? Alright. So it contains lower limit and upper limit. Next is class boundaries. So this is the one that I'm telling a while ago with regards to your class intervals, no? When we say class intervals, the intervals of your class, correct? But with regards to your class boundaries, it will refer, again it will refer from your class interval. What is that one? If this is your class interval, CI, no? Your CB, you will be depending to your CI. And how is that one? It is told that it is half a unit below the LL, below LL, no? If this is your LL to upper limit, lower limit to upper limit. So, your class boundary defines that it is half a unit below the LL, half a unit, and half a unit above LL. This is your 1/2. So, what is a half? What is a half? For example, you have, let's just say, an example of 12. 12 to 15. What is the half of a unit? When you say unit, what would you, how would you identify a unit? For example, a square unit. Of course, you are referring in one unit, correct? So the half of one unit is 1/2 or 0.5. But when you are referring, for example, your data is all about decimals. For example, 2 point, no. Let's make it in this one. Let's make it as 0.3. Ayan. Okay po? So, what you will be doing that, 0.3 up until, this is your class interval, 0.3 to 0.6. Half unit below this one is that the class boundary is 0.25. Okay? And your 0.6 will become 0.65. Okay po, that is the class boundaries, no? There is a purpose of that one. Okay? So, next in line, we have class mark or the midpoint. So, when we are referring to midpoint, that is the midpoint, no, of the lower limit and upper limit. We are going to divide it by 2. Again, people, this is not the average because most likely when they saw like they are adding them, they are dividing. That is not average. When we are just referring to midpoint, it refers to the, when we are telling mid, correct? We commonly use the starting point and the last point. Then we just divide by 2 to get the middle one, right? So in this case, we will be able to find the midpoint with the denominator of it with the 2, the value of 2. If you have 4 plus 6, no, that will become 10. And if you divide it by 2, the middle one would be 5. Okay po? Alright. Next in line, we have this class size. So I already mentioned this one, what is the class size before. This is also referred as class width. When we say class size, it can also called as class width. It can also called as class width. Class width and class size are just the same. And that is the difference between the upper class boundary, again upper class boundary and the lower class boundary of a class interval. Okay po? Okay, sige po. In terms of upper class boundary, this is not the class boundary really, no? But when we are referring into class width, this is the upper limit, lower limit, then plus 1. Okay po? Okay? Alright. So, this one. Next in line. So, let's have the relative frequency. When we are referring to relative frequency, again, no, it is the rate. A rate of what? A rate of the frequency by dividing the frequency by the n. In what is n? What is n? N is the summation of fx. Correct. Fx. N is the summation of f. Okay? N is the summation of f. Or the sum of what? Sum of frequency. Okay? Alright. And how about this less than cumulative frequency and greater than cumulative frequency? I just noticed that there are some, no? There are some who are how's this one? Who are confused with regards to this less than and cumulative, less than and greater than cumulative frequencies. Later, I'm going to show you how is this one, how is this being computed, no? How is this from top to bottom and bottom to top? Okay, so there are two things that most likely the students are getting confused. These are the cumulative frequencies and the class size. When we are referring to class size, This one, when we are referring to class size, again, we have the formula of upper limit minus lower limit plus 1. And maybe you will be telling me, Sir Jai, why is it in the why is that when we research, the formula only is upper limit then lower limit? Please take note, in terms of upper limit and lower limit, it only defines with the class boundary. You're going to subtract this one, the upper boundary and lower boundary of the class. Upper class boundary and the lower class boundary. Later, I'm going to show it you. No, what's the difference of this one? Okay, so let's go already. Again, now cumulative frequency, and I'm going to show you how it is being worked. Alright, so let's have this example. No? So we are halfway already. So let's have this example. You have the raw data of these 50 students in statistics. No? Statistics. And these are the test scores of the students. So it is really many. No? In order for you to make it in complete frequency distribution table, no, first in line is that you need to determine what is your range. Of course, in identify the highest score and the lowest score. Okay, so with regards to this manner, no, what is the highest score? Your highest score is 90. Oh, where's the 90? Can you see where's the 90? Your 90 is in here. And where is your lowest score? Your lowest score is N1. Okay? Alright, so in that sense, you were able to complete the step 1. Determine the range. Okay? Okay. So, step 2. Step 2, after determining what is the range, you need, of course, you need the class interval. That's the big one. Determine what is the class interval. So, Sir Jai, how are we going to determine what is our class interval, and how many class interval that we are going to use? Because we cannot just simply say, sir, is it like always by 5s, 3s, no? So there are ideal numbers. How many class interval would be uh, uh, taken in your data? For example, you have 1 to 100 persons. Okay? So there are ideal numbers or range of numbers, like up until how many class intervals. So the ideal numbers is between 5 and 15. Okay? So you can choose like 5 class intervals, 6 intervals, 7, 8, 9, 10, or 15. No? No, so with regards to this one, let's have the ideal number. It's up to us already, no? So let's say the class interval would be 8. Okay? It would be 8. Okay. So once you have the class interval already, okay? So how are we going to identify? Because we know already, if we're going to write it down, the class interval. Okay, class interval, you have 8. For example, this are 8 class intervals. How about the range, Sir Jai? Because we know that when you have 50 students, would it be better that it should be 10 columns, Sir Jai? Then you have 5 class widths. Let's see, no? There is construction or proper way how to construct your intervals and your uh, class intervals and class size or class width, no? So next step is to determine the approximate size or class width from your class intervals. So from your class intervals, if this is your class intervals, no, with your range in your class intervals, if you will be trying to divide them both, you will be having the values of 5. So maybe you will be trying to search once again, no, the internet. Some of you will be able to find there is a square root. It's up to you already, no. With this manner, this is my way. And in terms of identifying which is which, no, if you are having decimal numbers in your class size, maybe it would be better, no, to check what is the better one if your number in your decimal number is about to reach the whole number. If that's the case, maybe you could round that off into the nearest whole number. If it's not, then stick with the whole number that it shows. Okay po? Alright, so that is the step 3. So next, step 4 is to construct a frequency distribution table. Of course, by making the class intervals starting with the lowest value. So in terms of writing it down, the class intervals. Now there are times that the values that you are trying to show is by the highest value starting from the highest value coming from up until to the lowest value. Or some cases, there are times they are showing the lowest value up until to the highest value. So again, no, it shows when we are going to construct, no, we're going to start with the lowest value, the lower limit of the first class interval. Again, lowest value. In making your class interval, or class interval, you cannot just simply have 90 to 89. You can just have the highest value. Okay po? But what I'm telling a while ago is that, for example, your arrangement is 80 to 90, and your lowest class interval is 4 to 10. For example, only this is highest to lowest. But there are times that it is arranged in lowest to highest. There are times, no? Okay, so it will depend already. Next, once you have this already, compute the class size to obtain the lower limit of the next class interval. In terms of class size, we were able to find what is the class size, right? Class size or class width. Okay? In that sense, we will be able to arrange it properly. And in that sense, if we're going to compute it, how many class intervals a while ago? We were able to have the 8 class intervals. So that is 4, 5, 6, 7, 8. And what is the class size? Class size. The formula is what? The formula is upper limit minus lower limit. Okay, plus 1. I'm sorry, plus 1. Plus 1. Upper limit is what? 90 minus 86. 90 minus 86 is 4 plus 1, that is 5. Okay? We have 5. And if you will notice, 86, no? 86, if you will notice, the interval between the numbers from your first row to your second row is 5. Correct? Because from your 81, you have 5 values. You have 5 values to get to 86. You have 82, 83, 84, 85, 86. What are those? 1, 2, 3, 4, 5. So there are 5 values. No? That's why we are referring also in the width of your class. No, you have given the formula of upper limit minus lower limit plus 1. Later, I'm going to show what's the upper limit minus lower limit. Okay. Next, after putting your class intervals, next in line is to write the obtained frequency from your class interval to your raw data. So if you're going to tally it, okay, you will be able to find the frequency. And in that sense, you will be able to double check if you were able to get the 50 students. So if it's not 50 students, there is something wrong. Maybe in the way how you check your data. Okay po? Next. Next in line is to determine the class mark of each interval. So if we're going to check the class mark, what's the class mark? Lower limit plus upper limit divided by 2. So if this is 86 minus 90, Lower limit plus upper limit, 90 plus 86. 90 plus 86. 90 plus 86 is 176. 176. Divided by 2, what's the answer? Divided by 2 is what? It is 100. 100, I'm sorry. The value is 88. Okay po? 88. And that's why we have 88. So, same goes by here. So, we're going to find the midpoint of this one. Class mark is midpoint, ha? We're going to find the midpoint of this one and this one. Okay? Alright. Next is that, once you have the frequency, the class mark, the class interval, you're going to put the class boundary already. No? So, when we are dealing with class boundary, the half of the unit of your lower limit and the half above of your upper limit. So, half below of your lower limit, what's your lower limit? 86. Half of your 86 is not really 43, no, but half a unit. A unit minus 0.5, and that would be 85.5 up until to half above. What's your half above? That is 90.5. So, let's deal with this time. With regards to the class size, because the formula of the class size is upper limit minus lower limit plus 1, correct? Plus 1. In some cases, you might see in the internet that it is only upper limit minus lower limit. That only tells that the upper limit of your class boundary and the lower limit of your class boundary. Again, from the definition that I just showed a while ago, I showed a while ago to you, is that the upper class boundary and the lower class boundary. And with that sense, no, you will be able to find what is the class size. So let's try, no, 90. Let's try this example. 90.5 minus what? Minus 85.5. Oh, what is the answer? 85.5. The answer is what? 5. Correct. Oh, either you try it already in this part, 90. Using this formula, upper limit 90 minus 86. Lower limit 86. That is 4 plus 1, 5. Correct? So, are they the same? Yes po. Okay. So, I hope it is clear already. Okay. So, this is another example. That is, by the way, that is how we make the complete frequency distribution table. Okay po? So, let's have this last example. No? So, the first step, again, if this is your raw data, the first step in order for you to make it, no, is to put the class interval, correct? Next is to put your frequency, right? And next is to put your class mark. Class mark, ha? Class mark. Next is the class boundaries. Or maybe you are confused already. Sir Jai, what is that all about? What is that all about? Maybe you're confused already. From what, no? From what given is that one? If you will remember, from the simple frequency in the complete frequency distribution table, no, we are using this example and not this example because this the lowest score here is 51, correct? The highest is 90. But in this sense, the next example is the first example that I've showed a while ago. The lowest score is 4, the highest is 51. 50. Okay po? Alright, so let's have it already. So the frequency is 50. The frequency is 2, 7, 8, 4, 11, 8, 6, and 4. And if we're going to get the class mark of that one, lower, upper, add them, then divide by 2. And you will be getting 6.5. Okay? 9 plus 4, the answer is 13. Divided by 2, you have 6.5. Next in line, get the class boundary. Class boundary of 4 to 9. Half a unit, 3.5 from year 4, no? And half unit above, 9 plus 0.5, 9.5. Okay? And same goes by to the others. Next, relative frequency. How do we compute the relative frequency? What's the formula? Frequency over n. What's your frequency? 2. 2 divided by 50. What's the answer? That is 4%. That is 4%, ha? 4%. Maybe you're wondering how did that value happen, no? So if you're going to compute 2 divided by 50, it is 4%. Just that you need to move it to decimal places. That's why it will become 0.4. Okay? Okay, next. Next in line is the less than cumulative frequency. When we are dealing in cumulative frequency, it shows, no, the starting frequency that you have, okay? Then it adds up the value with the next frequency that you have. So what's the starting frequency that you have? It's 2. Correct? So starting from your 2, you need to show the 2. And you need to add the value of your 2 to the next frequency. That's why we say cumulative. Cumulative, no? Adding with the next frequency. 2 plus 7, the answer is 9. So, what's the next frequency? 8. So, 9 plus 8, the answer is 17. And so on. Okay po? You're going to add up. So, that is the sense of cumulative frequency. But, what is the less than and greater than frequency? When we are telling less than, you're going to start your table or your frequency starting from the lowest to the highest. Okay po? Lowest to highest. How about for greater cumulative frequency? Highest to lowest. That's the essence only. Okay? So, what's your highest score? What's your highest frequency or the total number? It is 50. You subtract 2. 50 minus 2. I'm sorry. 50 50 minus 4. Sorry. 50 minus 4. What's the essence? 50 minus 4. The answer is 46. Here. 50 minus 4. The answer is 46. 46 minus 6. The answer is 40. 40 minus 8. The answer is 32. Same goes by up until to the end. Okay? So that is how we make the complete frequency distribution table. Are we clear? Clear po? Alright, so there are some slides that I will be showing you still, no? But that will not be covering up the frequency distribution table. Though we also have the next type of presentation of data, and that is graphical. So I will just summarize it. When we have graphical, you know it, no, that there are bar charts, histograms, no, pie charts, no, or contingency table. Those are the examples or pictograph, if you will recall, no. Those are the types of graphical presentation of data. But in a sense, our topic is up until frequency distribution table or the tabular, no? So to summarize, again, no, in terms of presentation of data, when we say textual, we are having the data presented in a paragraph form or in a sentence form. Okay, so when we are having the tabular, we have this what we call as frequency distribution table. So we have two things to remember. There are two ungrouped frequency table and group frequency table. Frequency distribution table, that one, ha. Okay. So in your frequency distribution table, we have what we call as well as simple frequency distribution table and complete frequency distribution table. Okay? So those are the things. So with regards to the graphical, no, we have this what we call as bar chart, histogram, frequency polygon, pie chart, and pictogram. No. So I would love to discuss this graphical, but our topic for this video is meant, no, to discuss the frequency distribution table. Okay? So with that said, I will not make it much longer, no? So I hope that you learned something for this time. And if you have some comments, suggestion, or questions, queries, clarifications, don't hesitate to leave it in the comment section. If you like this video, please hit the button, and if you want to subscribe, so you just subscribe. So once again, thank you for watching this recorded video. Next in line is the data with regards to our uh, measures of positions. Okay, measures of position. Let's have the central tendencies. Okay, measures of central tendencies. All right. So with regards to that one, thank you once again, and see you in the next video. Bye.